What's going on, guys? Today we are going to be taking our ESP8266 module and we're going to be programming it. So let's get right into it. Alright, so in this demonstration I'm going to be using a smaller breadboard, obviously the ESP that we made in the last part. So I'm going to go ahead and put this into the breadboard. So with this, I have it centered on the breadboard. And I would generally recommend having the antenna facing this way, just for reference for how I'm doing this. Then you're going to need some way of converting a USB signal into the RX and TX signal, which says on there somewhere. We're going to need that, so I'm going to go ahead and stick that in the breadboard like so, just for later use. We're going to need something to span the gap between this power rail and this power rail, so I'm going to go ahead and use this wire right here. So that's joining these two power rails, the positive, positive, negative, and negative. We're then going to need to ground the ESP, so the ground pin is this corner, is that pin, so we're going to bring that to ground. And then the pin right next to it, which is in GPIO, I believe it's GPIO 15, which is the one right next to it, that needs to be pulled down to ground with a resistor. And then you skip one, and so it's 4, so it's 4 from the ground. It's the fourth one from the ground, I should say. That is GPIO 0, which needs to be pulled low in order to allow this to be put into program mode. So if you don't have that there, it will not allow you to boot into the programming setting. The last resistor you're going to need is going to be the third to last pin on the top row. So 1, 2, 3. This is going to be the chip enable pin, so that enables this entire thing. So no matter what kind of circuit you have, the third pin has to have a resistor pulling it to the positive voltage potential in order to be enabled. Then you're going to need, so the positive pin is this corner, so that will be put to VCC, just like that. So we have the chip is getting powered, it's getting enabled, the programming mode is set, and the this GPIO 15 is what I believe this is pulled to ground. So now that you have all that, it is in a state of being able to be programmed. So another thing we're going to need is to plug in the RS or the RX and TX. So that will be going there. And then we are going to need to have, so the wires flip-flop, and then they go to the last two pins. So I'll probably need to show some sort of RX, well, this is RXD and TXD, so this and this. So the RX is this inner pin here, that's RX on this chip. These pins right here are the RX, and this is TX. So the TX goes over to the RX, and the RX on this chip goes over to the TX on this. So the transmit and receive pin, so the transmitter goes to this receiver, and this receiver goes to this transmitter, if that makes sense. Alright, so now we should be able to plug this in, but one more step we can take to make this better is to add a push switch. Now you don't need this. You can do it with just a jumper wire, but it's just generally easier. So you can put this pretty much anywhere. I'm going to choose right there. Then you're going to need a jumper wire. That's probably too short. you just need one wire to go from the very first pin on this side over to the button. So the very last pin on this goes to the button, and that is the reset pin. So then you're going to want, for this, you're going to want to have it be, you're going to need one more resistor for this step. You're going to want to pull this to VCC, or the positive voltage. Come on. And then once you do that, the other side can just get a wire directly to ground. Alright, so now that you have that, you need one more step. So on this, I have a positive 5 volts and a 3.3 volt, and then the ground on this chip, so I can hook up the wires on the back to what they need to go to. So the ground is the second pin on this. It is the second pin right there. So that needs to be hooked up in order to power up the chip. So that goes there and hooks right into ground. So our USB to, I believe it says it's a TTL. What does it say? It says USB to TTL, or USB to serial, or I'm not really up to snuff on the whole USB languages and stuff. So you get the ground hooked up, and then the 3.3 volt is the last pin right there, and that needs to go to the red, or the positive voltage rail. So now the chip is hooked up to the ground and positive of this USB, which is 3.3 volts. There's also an option for 5 volts. Now, a lot of people say that 5 volts will kill this chip, but I've tried voltage dividers coming from the RX and TX, well, no, just on the transmit of this thing going to the receive of this, and it never seems to work for me. So now you may want to be safe and use a voltage divider to lower the 5 volt data coming from this to the chip, and limit it to 3 volts, but it never seems to work for me. So I suggest, if you're having problems with using a voltage divider, to just directly wire it, because I've never, like, I have one of these chips in use where it's getting powered by 5 volts and the data is 5 volts, and I haven't had a single problem. It works phenomenally. In fact, if I run it on 3 volts, it doesn't have enough oomph to power on and off the MOSFETs that I have correctly, which of course, I mean, there's a solution for that, but the easiest way to do it is to have it be powered by 5 volts, and that's just how I do it. Alright, so now we can go over to the computer and mess around with this. Hey, we are at the computer now, and what we're going to do is open up an Arduino sketch. And what we're also going to do is go ahead and plug in our ESP. So now that that's plugged in, you can see the lovely... I recommend having some sort of USB extender. So now this is plugged in, and what we can do is go to Tools and look, and we can see that it should have a port here, and you're gonna need to have the ESP8266 libraries installed. In order to use the ESP8266, you need to copy this link into this, and once you do that, you can hit OK, and then you need to go to Tools. You need to go to Include, Manage Libraries. This whole thing will pop up, and then you gotta search ESP8266 and make sure that you install it. Gotta wait for this to load. Just go ESP8266, and then you should. So, like, just say, for instance, this says just ESP8266. Just go over and click install. That's all you have to do. It will install it. and then you're good to go. But since mine doesn't have that option, since I don't have that option, I'm just gonna say it. So once you do that, that's what you need to have. And if you're gonna use the Blink sketch, you're gonna have to download the Blink library, which is, if you just look up Blink spelled, where's my, there it is. You just use the Blink like that. Just look up that Blink. I'll have it in the description as well. And then you just you just hit sketch, include library, add zip library, and then go find your Blink library that you downloaded, probably from a GitHub, and then that's it. You have those two installed, and it will let you install it. So you're gonna want your code to go here, so you can use, you know, whatever kind of thing you can use. What's it called? Blink, and you can go ahead and go through and add like a Blink sketch. So you can go Blink. Which one is it? Wi-Fi, Blink Wi-Fi, and I do the ESP standalone. Let me check this to make sure that yeah. So on this, you would just put your network name here, your password here, and through Blink, the Blink app, you can put your authentication token there, and then you would upload this. And actually, we can go ahead and upload that just so you guys can see. So as it sits, when you plug it in, it should boot automatically into the programming mode. But if it just to confirm, you can hit that button and it'll blink and whatever, and then you're gonna go ahead and click upload. It's going to compile, and I don't know what it is about my computer, but it compiles extremely slowly. I wonder if it's going to give me a problem because I don't have the Blink. I have that, it doesn't obviously know that. Oh, it's uploading, and as you can see, it's connecting. Now it says writing. It's writing to the SP, and you can see that it's blinking. I don't know if you guys can see that. You can see that the LED on the board is blinking, so that's a good sign. Plus it says writing. So now it says leaving, hard resetting via reset pin. And so this does not have the reset pin. So what you have to do is remove this resistor, the second resistor on GPIO 0. You gotta pull that out and then hit the reset button. And now it is going to be running the program on the chip. I'm going to go ahead and put this back for now and upload a different sketch onto this. So I'm going to put it back into programming mode, and I'm going to upload a different sketch just so you guys can see. It's not on the screen right now, but I'm uploading another code, and so I can get rid of this. And so we can be looking at this. The code just has some, you know, somewhat sensitive information, and I'm not about to blur it. So, all right, I can reset it. So we gotta remember, pull out that resistor, hit the reset button, and we can pull up the. So you go to Tools, Serial Monitor, boom, right there. You get the day and the time, updates every second, just like that. Now I just looked up and found this code just as an example, so you can use that for any sort of project. Alright, so now that we're back over here, I'm going to be going over the integration with an Arduino, and it's the same, pretty much the same for Nanos and Unos. So what you're going to do is remove this, get rid of it, don't need it anymore, and then you're going to need, again, some more wire. Okay, here's some of the wires you're gonna need. So you're gonna need ground. That's going to need to go to the ground pin. You're going to need 3 volts. That's going to be going into the positive rail. You're going to then need your RX, which is going to go here, your TX, which is going to go here, and then we'll go back over to the computer. Now I'm not going to have live footage of this like I did before because I don't want to move the camera again, but it's literally just plugging this in, changing a few settings, and then you're done. So let's go do that. As it turns out, unfortunately, I cannot seem to get my Arduino to program the ESP, so I don't recommend doing it that way. I would recommend using some sort of UART device. So, yeah, I mean, if you're in a pinch, you might be able to try to get the Arduino to work, and some of the things I was reading just to make sure I was doing it right. It said TX to TX and RX to RX, which would make sense because the Arduino, that's the receiving pin and the transmitting pin, so so if you were doing that, make sure that the RX goes to RX. The RX on the Arduino goes to the RX on the ESP, and the TX goes to the TX. Just because with the UART device, it's you have to flip them, but the Arduino is being sent the code. But yeah, so I mean, it's pretty much the same thing. You just wire it up differently, and then it's the same process. So, yeah, unfortunately, I won't be showing how to actually. I won't be showing the process of programming it with the Arduino in this video. If I get it to work, I will do a follow-up video. I probably won't unless I think it's a good idea. The next video in this series of ESP projects will probably be making a programming board that will allow me to just like insert the bare ESP, so it won't need to be breadboard friendly. It'll just be like you set it into a little thing with the bare minimum amount of pins. In order to program it, I'll have pretty much a direct hookup to the UART device. So you'll just set the ESP into the holder, essentially, like a EEPROM programmer, like one of the ones you just set in and lock it. So that's essentially what I'll be doing, just on a solder perf board. Well, I'll try to, in the video, is probably going to be me actually making it for the first time for myself. So we'll see what happens when we get there. I think that's all I really wanted to talk about the future of this series. Actually, I will probably be going over the home automation side, as far as like the Blink system and going through IFTTT, IFTTT, if this then that, the website, in coordination with Blink and that stuff, in order to like be able to say, hey Google, overhead lights 100. Hey Google, overhead lights 1000. I'm sorry if you have a Google Assistant. But yeah, so I can go over modifying existing lights, like the overhead lights or the ceiling light in my room right there. It's controlled by, it has a remote control, and I wanted it to be able to be controlled by Google, so I modified that, and in the last video I had a picture of it. So if you guys are interested in learning more about that, then I will make a video about it. So just let me know down in the description. If you like this video, leave a like. Tell me what you liked about it. If you would like to see something else, or
maybe you want me to go back over, like if I didn't clearly say something, you can always ask in the description. And if there's something large you missed out, it'll be the first thing in the description, pinned. But yeah, talk to you guys in the next video. Bye.